And now we would switch over to the pins, and again, this is the one place the face is going to go away from the jig. And to give you an idea of how this cut, it cut like this, and will come around like that for assembly. Again, the 3D visualization here, as you work with this jig, it helps an awful lot. Now, I'm going to flip this over, and when you look at this side, you will see a myriad of little number markings here. And you remember that A dimension I talked about, which was 1/2 inch in this case? That is the diameter of this bit across the flats. And that is the critical dimension you set into the jig. Now, I happen to know this jig is pretty dead on, so I'm going to set it right to the 1/2 inch setting. And you have to set it exactly on both sides to put this parallel. But actually the instruction manual recommends that you start with a setting that is 1 or 2 graduations with the comb in this direction. Now if you notice for this type of dovetail, this comb uses a tapered finger right in here. Can everybody see that this is a taper? And the adjustment of the fit of the dovetail is achieved by finding the right place on that finger to cut it the right size. So if we slide this a little forward, we're going to start by cutting it too big because we're on a bigger part of the triangle. And we can actually, it's accurate enough that we can put the work back in the jig and keep creeping that graduation till we get exactly the fit we want. And then we should go someplace and write that setting down because it's the right setting for our guide bushing bit combination. Okay, we'll go to the other router now. Can we fit that in there too? And again, I'm going to adjust the height. I would try to pick up guidance off the left side of the finger as I went in and then go around through the back of it and put pressure against the right-hand side as I come out. And that puts me in a climb cut, which is desirable here. With this half of the joint, really the area under the fingers is what's going to be left, and I'm going to route out everything in between. And if you route sort of ham-fisted on this, you'll get terrible results. What you really have to do is climb cut this. And a climb cut is really routing in the wrong direction. We try to route into the direction of the cutter. The cutter is turning this way. So if I put it against this face, I would normally cut this way. This is a very small cutter, so I go in the right and I climb cut across. I will then plunge through against the left-hand side of the finger, climb cut across the back and come out, and then just climb cut in a circle or an oval until I've taken all the wood out of there. And I'll get a very clean cut that way. If you route this with a normal method, you get a horrible cut. Climb cuts give better cuts. Much better. When you use a tool the way it was designed to be used, it always works better. I don't have a perfect alignment of these, so what I'm going to do is now simply cut the other end of this one. And since we have everything set up, you'll now see how quick this can go. And they really do fit nice. Yeah, I mean, look, the guy even scribed a gauge line there. That guy knew what he was doing, you know? The rule of thumb is that you always, of course, want a half pin at each edge. And then you put your intermediate or full pins at least every 3 inches. In reality, you tend to usually try to find what would be 3 inches and then sort of evenly space them within that, and you usually come out to less than a 3-inch spacing. But for integrity, you need a pin at least every 3 inches. The same rule for biscuit joints. Yeah, and in its through dovetail capacity, it even works in about the same way. It has little fingers that you can lock on tubes across the face of the jig. What I don't like about the Porter cable, as you'll see in a minute, this is the only jig that you have entire freedom of spacing on all joints that you make with it. You can make those pins and tails at any spacing you want to make them. With the Akita jig, you have a good deal of freedom, but it's still by 1/8 of an inch. So if you've got a drawer height that's in the 16th, you may have a little bit of a problem there. With a Porter cable in half-blind dovetails, you are limited to templates that they graduate in certain graduations. I think it's in like 2-inch increments or something like that. Well, now that one is strictly the first one we talked about that does an even, and there you just sort of space the piece to give you a half pin at each edge. But in the better one, the Omni jig, it will do odd spacing of through dovetails, but only within the range of their templates. So you don't have total freedom of building a drawer any height you want to build it, which bugs me for some reason. I do not like design being a slave of procedure. I like my tools to allow freedom in design. Climb cutting versus, and that's a very good question, and one that is poorly understood. When we are hand routing, we have the cutter traveling in this direction, and if we just had a big round cutter like this and we had a board that was clamped but overhanging the bench, and let's say we had a pilot bearing on the bottom of it, that actually would be a dotted line because we can't see the pilot bearing from above. But as we started to put that pilot bearing against here and cut through here, we would want to cut in this direction because we would get a nice smooth cut and no problems. If we tried to cut in the other direction with the bearing here, the bit is still traveling in this direction, remember. What would happen is the bit would walk up onto this surface and it would actually power the router. It would start dragging it violently to the left and a little bit back at you too. And so bits today are even what they call safety bits, and in a safety bit the cutting edge would be here like this, and they put a backing in here sloping away so that this thing can't cut too deeply with each rotation. There's saw blades made this way. You may have seen saw blades that they have the carbide here and then it has like a little thing up here that keeps that tooth from taking too much with each pass, and that helps to reduce kickback. But at any rate, when you climb cut, the router sort of zips away from you. It powers itself. And but a climb cut, on the other hand, doesn't rip out. Here, because the cutter is coming out the side, you tend to get a breakout along this edge. Where when you climb cut it, it's going down and into the edge, and so you get a much cleaner start of a cut. If you have a rabbiting bit and you're trying to rabbit out the back of a carcass, if you cut in the right direction, it usually looks like shrapnel at the edge of the cut, and it's all splintered, and especially in plywood. Where if you just go in there and purposely, knowing that the router is going to drift a little, but you're sort of ready for it, if you climb cut that around there, and it won't cut to its full depth. You usually have to go around 2 or 3 times to make it cut to the full depth. But you'll get a rabbet that's just perfect because you climb cut it. And that's the same thing here. Instead of going in on the left side of the figure and cutting across and breaking out the back, I am actually climb cutting the wrong direction, then going through, climb cutting across the back, coming back out, and then climb cutting in a circle. So if you were looking down on that, you have the board here, and you have the fingers here, and you're going to cut all this material out. So my router starts here, and I climb cut across here, and then I cut right through like this. I climb cut across here, and then out, and then I'm working in a circle like that.